A very good morning, children. In the yesterday video, we learned, or the day before video, we had learned about the equilibrium. Do you remember the concept, children? Yeah, very good. Here, in this video, we are going to continue with the concept where we left in the previous class. What are the general characteristics during a physical equilibrium? So this is the small concept. Then after we will go with the chemical equilibrium. Actually, what did we learn, children? During a equilibrium condition. During the equilibrium condition, which equilibrium conditions we have learned yesterday? When a solid is changing into liquid. When a solid is changing into liquid and the liquid is converting back into solid, we say they are at the equilibrium. Is it not? So, what will be a constant value during the reaction? What will be a constant value during a reaction? Now, what is the melting point of water, children? Everyone will say above 0 degrees Celsius. Ice cube will melt into water. Is it not? So, it is a constant. No one can change it. So hereafter, what we want to remember is, for every solid, when it is converting into liquid, it will have a constant melting point. It will have a constant melting point. So during the conversion of the solid to liquid, its melting point is constant. Means at that point, the amount of solid converting into liquid again converting into solid will be occurring at the same speed or the same rate. So it takes place at that constant melting point. And do you remember when a liquid is changed into gas and the gas upon condensation into liquid, what will be constant? Yeah, vapor pressure will be constant. Vapor pressure will be constant. What is constant, children? Vapor pressure is constant. So, for one type of equilibrium, one value is getting constant. Is it not? For one type of equilibrium, one value is getting constant. And we had also seen solubility of solid in liquid. Solubility of solid in liquid. Do you remember what is constant? Yeah, the solubility is constant because if you have the third spoon of sugar, it is trying to enter into the liquid water, and from the water the sugar molecules are again converting or settling to the bottom of the container. So what is constant in that one? The solubility. The solubility of the solute is constant. The solubility of the solute is constant. And the solubility of gas in liquid. Solubility of gas in liquid. During the solubility of gas in liquid, the concentration of dissolved gas in the solution will be constant. What is constant? The concentration of the gas in aqueous medium. To the concentration of gas, or we can simply speak the concentration of gas remain constant. So during different kinds of equilibrium, one value will be constant. So what is our present concept? Our present concept is general characteristics of physical equilibrium. At what condition does the physical equilibrium takes place? The physical equilibrium takes place only in a closed container. When the physical equilibrium takes place, it takes place only in a closed container. So that's what our first point. It takes place only in a closed container. It takes place only in a closed container. are at equilibrium. When we say they are at equilibrium, when the rate of forward reaction is equal to the rate of backward reaction, they will be at equilibrium. Or say both opposing reactions undergoes at same rate or at the dynamic equilibrium happens. So what we say is opposing reactions takes place at same rate, that is they are dynamic equilibrium process. They are dynamic equilibrium process. They are another dynamic equilibrium process. Is it not? What is the dynamic equilibrium? When the rate of forward reaction is equal to the rate of backward reaction happening at the same speed, we say it is at the dynamic equilibrium. And during this physical equilibrium, all measurable properties will be constant. What is the one more property what we observe, children? During physical equilibrium, all measurable properties will be constant. All measurable properties means volume, pressure, temperature, this we can measure, no? They will be constant. And during each kind of equilibrium, during each kind of physical equilibrium, one value will be constant. You can see here, during the solid equilibrium, what is constant? Melting point is constant. Liquid gas equilibrium, vapor pressure is constant. Solubility of solid in liquid, solubility is constant. Solubility of gas in liquid, concentration of the gas is constant. So during each physical equilibrium, one property will be constant. Means you must refer this chart. The chart. So the above said conditions will help us to understand up to how much extent is the equilibrium process attained. So above conditions helps to study the extent of equilibrium achieved. What is the last point, children? The above conditions will help to study the extent of equilibrium achieved during the physical equilibrium. So these are the characteristics of the physical equilibrium. So now we are going to the next important concept of this chapter starts from the next topic. This is just an introduction topic. I hope you understood. Once again, revise the video. Now give the heading chemical equilibrium. Before you give the heading, let's write down this all into the notes. Up to now we had learned about the physical equilibrium. Now we are learning about the concept. Here we say the concept that we are going to learn is called chemical equilibrium. Right, from here our actual concept starts. Not only with this, we are also going to learn with one more point that is called law of chemical equilibrium. What is the concept we are going to learn? Law of chemical equilibrium. For this, let us take a very simple example. The simple example that we are going to learn is the manufacturing of ammonia. What is the concept we are going to learn? For example, we are going to start, then we will go into the concept. Manufacturing of ammonia. In the manufacturing of ammonia, what are the reactants you want, children? What are the reactants you want? You want the nitrogen gas, and you are going to react the nitrogen gas with hydrogen gas. You are going to react the hydrogen gas with the hydrogen gas. Under the conditions of 723 Kelvin temperature, and 200 atmospheric pressure. Then it will form 2 moles of ammonia. moles of the ammonia gas. But during this reaction, the change in enthalpy, it is generally a negative value. It is generally a negative value. Negative value means it is an exothermic reactions. What is this one? Exothermic reaction. So, generally during exothermic reaction, if there is a more amount of temperature, again the reactants will be formed back. So we are bringing here the word called nitrogen gas and reactant. Hydrogen gas are forming ammonia, but the formed ammonia is again returning back to form the nitrogen gas and the hydrogen gas. So the double arrow, the rate of forward reaction, when the rate of forward reaction is equal to the rate of backward reaction, the system is at equilibrium. We are studying this equilibrium regarding an example called manufacturing of the ammonia. So taking this one in the place of hydrogen gas, if you choose the isotope of hydrogen, what the hydrogen isotope we have? Deuterium, that we can use in this reaction. The deuterium, once you react in this reaction, like 3 moles of deuterium if you take, it is again forming deuterium in the place of hydrogen. It is also happening at the same rate, means rate of forward reaction is equal to rate of backward reaction. So this isotope deuterium helps us to study how much of speed the reaction is taking place or how much of rate the reaction is taking place. So we already learned the isotopes have the same chemical properties. So even if you hydrogen or if you use deuterium, rate of reaction is the same in the manufacturing of ammonia. So what this is saying, the rate of formation of ammonia is equal to the rate of decomposition of ammonia. Rate of formation of ammonia is equal to rate of decomposition of ammonia. Means they are becoming constant. What are they becoming, children? They are becoming constant at the equilibrium point. So instead of taking this example, we can take a general equation. What we can take a general equation. Let us speak. A general equation is given like a reactant A is there. It is reacting with reactant B. These both are reactants. They are forming to give C and D products. But after some time, the C and D are returning back to give A and B. At this point, at the equilibrium, we are speaking the rate of forward reaction is equal to rate of backward reaction. We are bringing one term called as the equilibrium constant. What is the term we are bringing here? We are bringing a term called as the equilibrium constant. The equilibrium constant means at equilibrium. There will be one constant value measured. The equilibrium constant during a chemical reaction is given as Kc. What is the term given as the Kc? What is this Kc? It is the ratio of concentration of products by concentration of the reactants. What is it, children? It is the ratio of the concentration of products by concentration of the reactants. It is equal to the ratio of concentration of products by concentration of the reactants. And in this reaction, what are the products formed, children? The products formed are C and D. And here, what are the reactants? A and B. So, can I write Kc is equal to products C and D. What are the reactants? A and B. So, how can I define the equilibrium constant? It is the it is the product of the reaction products to the product of reaction reactants means the product of the reaction products to the product of reactants are equal to a constant value called Kc. This was given with this law. Which law? The law we are calling as law of chemical equilibrium. Here we can write the equilibrium constant for any reaction. By applying this simple terminology. Can you write the equilibrium constant for this above mentioned equation of manufacturing of ammonia, children? Yeah, write the equilibrium constant for manufacturing of ammonia. Equilibrium constant in manufacturing of ammonia. What are the products we got? NH3 got. What are the reactants we have? Nitrogen gas and the hydrogen gas. How many moles of nitrogen gas we got? 2 moles of ammonia. We got 2 moles of the ammonia. What are the number of moles of nitrogen gas? 1 mole. What are the number of moles of hydrogen gas? 3 moles. So whenever you are writing the equilibrium constant, you will try to raise the product concentration to its coefficient. Let me say, during this reaction, a general reaction, reactant A coefficient is B, reactant B coefficient is B, reactant C coefficient is C, the product G coefficient is D. So whenever we are writing the equilibrium constant, we set the product of the concentration of the products upon the product of concentration of the reactants are equal to a constant value. But here their concentrations are raised to some coefficients that are there in the reaction. So what is the coefficient of C, children? Coefficient of C is small c. I raise it to its power. What is the coefficient of the D? Small d. What is the coefficient of A? Coefficient of A is A. What is the coefficient of B? Coefficient of B is small b. What are these coefficients? These coefficients are the number of moles of the reactants or products that are participated in the reaction. Now can you write the equilibrium constant for the above reaction of ammonia? Yes, Kc is equal to concentration of the products raised to their coefficient upon concentration of the reactants raised to the coefficient. Here only 1 mole is there. And how about hydrogen here? How many hydrogens are there? Hydrogens are 3 moles. So this is a general equation that you can apply for any of the examples that are given in the examination. And this is one of the explanation we brought forward from it. Let us take one more example and we can apply that equation here, children. I am going to react hydrogen gas with iodine gas. It is going to form hydrogen iodide. At equilibrium, the formed hydrogen iodide may decompose to give hydrogen gas and the iodine gas. Generally, this is a purple in color. Which is a purple in color? Iodine is a purple in color. When the purple color disappears in the reaction, we say it is converting into hydrogen iodide. Or if you take the starting as hydrogen iodide, it may decompose to give the iodine gas. Means purple color will be intensified in the reaction. Now can you write equilibrium constant for this reaction, children? What is the equilibrium constant that we can write for this reaction? Concentration of the products raised to their coefficient upon concentration of the reactants raised to their coefficient. What are the products found here? Hydrogen iodide raised to their coefficient. What is the coefficient? We got here 2. And what is the concentration of hydrogen? Hydrogen concentration is only 1. What is the concentration of iodine? Concentration of iodine is given in this manner. constant. Once I write the definition of the law of chemical equilibrium on the board in the meanwhile, you please copy this all. Let us see one problem on this equation what we have learned, children. The question is given like this. The following concentrations were obtained for the formation of ammonia from nitrogen and hydrogen at equilibrium at 500 Kelvin. 500 Kelvin. Concentration of nitrogen is given as 1.5 into 10 to the power minus 2 molarity. Concentration of hydrogen is given as 3.0 into 10 to the power minus 2 molarity. Concentration of ammonia is given as 1.2 into 10 to the power minus 2 molarity. Calculate the equilibrium constant. What is the formula to calculate equilibrium constant, children? Equilibrium constant is equal to concentration of the products upon concentration of the reactants. Is it not, children? Concentration of the products upon concentration of the reactants. But first we want to generalize the equation for this reaction. What is generalized equation that we know? Nitrogen gas combines with 3 moles of hydrogen gas to give 2 moles of ammonia gas. To give 2 moles of the ammonia gas. Now, when you apply the equation here, Kc is equal to concentration of the ammonia, because the different product formed in this reaction. Raise it to its coefficient 2. Concentration of the reactants. Nitrogen gas is only 1 mole and hydrogen gas, how many moles are there? 3 moles are there. So they are raised to the power of 3. What is the concentration of ammonia given? 1.2 into 10 power minus 2 whole raised to the power of 2 upon, what is the concentration of nitrogen given? 1.5 into 10 power minus 2 into, what is the concentration of hydrogen given? 3.0 into 10 power minus 2 whole power 3. Is that not right? Now can you write this equation as 1.2 into 2. So 1.2 into 1.2 into 10 power minus 4 upon 1.5 into 3.0 how many times? 3 times. 3 into 3. 3 3s are 9. 9 3s are 27. So 27 into, here 10 power minus 2 into 3. 6 is there. Here minus 2 is there. So total 10 power minus 8 is there. So the 4 and 8 is strike down and you complete your calculation and you express the value how much you are getting. That will be in the value of 10 power 4. Here still 10 power minus 4 is there now. When it is going for the numerator, it will become 10 power 4. And upon calculating, you will get some value, enter the value here. So this is what generally you will be using to calculate the equilibrium constant in any of the given question. I hope you understood. Thank you. In the next class, we will see how to calculate the equilibrium constant in regarding the gaseous reactants and products. That will be used with the equation called from the ideal gas equation where PV is equal to nRT we had learned. Thank you, children. Have a nice day.